Thank you, Drew. Thank you, Bill. You know, as nuclear energy, the first one always harder. The second one, everybody compete for the second one. So thank you for laying the stage here. So, so first of all, so my name is Stephen Cohn. I'm the Office Director for the Office of Material and Chemical Technologies. We call it NE43. So I will give you a brief mission and program stewardship introduction. So my contact information is listed below just for your information. So who are we, first of all? Next slide, please. Oh, you can see here. So it's not red color, but it's, you can read in the bottom, the middle, the red circle is we NE43. We call the Office of Material and Chemical Technologies. So we sit under NE4. You can see, of course, our big box is Dr. Huff on the top. So my direct box is Dr. John Carmack. He's a new DAS, Deputy Assistant Secretary for NE4. So we are a bunch of within NE43. We are a bunch of chemists, chemical engineering, and material scientists, and material engineers. So next slide, please. So yes, here shows who we are in our office. So unlike unconventional nuclear energy office, most of people are nuclear engineer or physicists in training, but we are chemists, chemical engineering, material and material scientists, as I mentioned. We provide unique capability and stewardship of the NE program here. So first on the upper left is Dr. Bill DeCool. So he's a chemical engineer. He managed the aqueous separation and the vapor phase separation, and also hybrid Zersex. And then the second one is Miss Kimberly Gray. She managed off-gas capture and the immobilization, advanced wasteform development. And then myself and the office director in the third. And then in the bottom left is Miss Sulaska. She's a material engineer. So she helped manage all the material coordination within the NE program office. Specifically, she also managed NE5 art and the light water reactor sustainability material R&D program. In the right side, see, we have Miss Tencel Selector. She's a nuclear engineer. So she helped us to manage the material protection, accounting, and control technology. And she also managed EBR2 for HALO production. And then in the middle of the right side is Dr. Ming Tan. Dr. Ming is a material engineer in training. So he helped us to manage innovative new nuclear materials. So this is a relatively new program with NE4. So I will cover that later on. And then on the bottom right side is Dr. Jim Willett. So he's a chemist in training. He helped us to manage the pyroprocessing, molten salt chemistry, and the salt fuels. So next slide, please. This is what the program we steward. So here, first of all, is material recovery and wasteform development. It's a fancy name for in the old time we call the reprocessing and the recycling. So reprocessing is only the chemical process we use it, but our goal is to recycle and reuse. Is our goal here. So within our mission for this program is to in four areas. The first one is to improve the resource utilization. Of course, recycling can improve uranium utilization as well as material utilization, but that's a different topic we are talking about later on. And the second one is reduce the repository burden. So hopefully we can reduce the waste volume and of high-level waste. And then the third one is a limited proliferation risk. So we can address the proliferation. In this case, we do not want to separate plutonium as a separate stream. So instead, we have a combined stream with uranium. So plutonium, sorry. So then the last one is that we try to address the economics of the separation technologies. So our implementation strategy, so basically can cover 4 topics in the bottom here. So the first one is we are supporting the HALO production. So in this case, we are recycle the EBR2 material fuel. So it's a high HEU material. We're trying to recycle those material to downblend to HALO material for advanced reactor fuel fabrication R&D needs. The second item we are trying to address the the material separation recovery challenge for various advanced reactor designs. So as you know, not unlike the conventional reactors, they will always use oxide fuel. In this case, in the advanced reactor, we may have metal fuel, we have oxide fuel, trisul fuel, or even salt fuel or nitrite fuel. So we are addressing all kind of fuels recycling area there. The third area is to address the economics. So currently, of course, the technology is not really economically feasible at this time. So, but we're trying to develop simplified process, trying to reduce the plant size of the plant footprint. So in this case, we can address the economics of initial building a nuclear recycling plants. The last one is the most important ones. This program to steward and to expand the capability and the knowledge in nuclear chemistry for a broad range of nuclear applications. So we are using this separation program to support nuclear chemistry, which can apply to many other areas, including isotope production, other areas as well. So next slide, please. The second stewardship areas in our office is called material protection, accounting, and control technology, called MPAC. So our mission is to support U.S. advanced fuel cycle technology developers to effectively and economically address nuclear material control, accounting, we call the MC&A requirement. So within this program mission space implementation strategy, we're trying to develop innovative real-time or near real-time technology or an analysis tool or advanced integration methods to improve or to enable U.S. domestic nuclear material management and safeguard our emerging nuclear technologies. So we also work with industry or stakeholder early to develop a safeguard by design process. So next slide, please. Yes, so this is the new program within CINR called Innovative Nuclear Materials. Our mission is to develop next generation of nuclear cladding and in-core materials. And then we're also trying to address the nuclear material recycling and reuse issue. In this case, it's not radionuclides or actinides. That's covered by previous program. But our material program, in this case, we recycle like zirconium or other reusable materials. So in this case, we can reduce the repository burden. And I'm not going to take details about this one. So one major key strategy for implementation is we're trying to build the next generation of material scientists for nuclear energy applications here. So we also want to build the R&D capability at national laboratory as well as universities. So next slide, please. I hope I didn't go over time here. I have more slides here. So here is shows our current supporter, our customers for the from national lab and universities. So it's about 8 national laboratory in the red dots here. So we support in our program, and about 30 some university in the past 5 years we support. If you are one of those universities in their list, I appreciate your continued support. If you are not there, please consider submit proposal to our program. So we love to work with you. So this is the quick update of what we are, our customers here. Again, next slide, please. And finally, I want to cover this FY24 FOIA topic under NE43 program. The topic area 4, nuclear fuel recycle and technologies. So we cover the innovative aqueous separation, that's under BuildCool, and advanced oxidation and vapor phase separation, that's under again under BuildCool, and molten salt process and the salt chemistry under Jim Willett. And then under topic 5, fuels, we have molten salt fuel under Jim Willett. And under topic number 10, license safety and security, we have a material recovery and impact program called MC&A method and a tool for fuel recycling process, that's under Tensile Salakler. And then lastly is topical area 11, advanced nuclear materials. So we cover 2 topical areas in that. One is innovative cladding materials under Min 10, and then the last one is a new material for off-gas capture and wasteform material development. So under Kimberly Gray. So that's all I have, I believe. Thank you for your attention.